please.
Yeah, participants, thanks for joining and welcome to the today's webinar. It's actually a virtual fireside chat series. The topic for today is data science marries chance discovery, the future of business intelligence. Here we have Dr. Ajith Abraham, Vice Chancellor and Dean School of AI at Sai University, and also Dr. Yukio Ohsawa, from the
Hi.
University of Tokyo, Japan. Welcome, sir. Very warm welcome. And Ajith, sir, over to you. Thank you.
Thank you. Thank you. First of all, I would like to formally say thank you to Professor Yukio Ohsawa, the University of Tokyo, for joining the School of AI as a research professor as well as an advisory board member of the school and the university at large. So, on behalf of the university, I would like to especially thank Professor Sawa for taking out his time for mentoring our university, our school, our students at large. And second, I would like to especially thank Osawa for uh, saying yes to this fight chat series. Actually, it's the first in the series, and when I sent him an email, he straight away told yes. So that is that is a friendship we have. I guess we met first time. I remember correctly, it was a 2007 in Jinan, China. So it is like about nearly 20 years of friendship,
Yeah, yeah.
and
Yes.
I'm glad that we are treasuring this. And over time, we have been doing a lot of things very nicely. And apparently, I also made a mistake with the timing. Actually, I thought it was 2.5 hours uh, ahead for him, but told me it's already time. What is going on? So I was then only I came to know that it is 3.5 hours. Tokyo is 3.5 hours ahead of Indian Standard Time. So I want to formally apologize for this mistake from my part. I again want to thank you for considering this change and again for being with us. So just a formal introduction, short introduction. So if you go to our school website, you can find this detailed biography. So Professor Osawa obtained his PhD degree from University of Tokyo in 1995. So it's almost uh, 30 plus years ago. Currently, he is a professor of system innovation at the University of Tokyo, and he has been working in Japan as well as closely connected with various labs and universities around the world. So the first time I'm hearing chance discovery was, I think it's in 2007 when I was hearing Professor Osawa in a plenary talk in China. So I am familiar with chance discovery since then, and I was closely following up with various activities and the impact which a chance discovery could do, in many scientific disciplines. So Professor Osawa has widely published a lot of articles, and he has obtained a lot of funding. He has been working on real world problems. So that makes the research more fascinating. Sometimes you don't see the results in some journals or in patents, but you will see some real life things happening, in the community or in the society. So I think Professor Sao is closely connected with the community and society in Japan very much, and you will hear from him soon. He has been a guest editor of several journals. He has been the chair of IEEE TC Technical Committee for a few years, and I think those days I was also chairing some of the sessions. So we had been working together, in many domains the last several years. So, for those who are new to this topic, I would like to give a quick introduction. So, data science is all about, finding meaningful information from data. So, data could be structured, unstructured, and sometimes, we need to obtain data. It could be, very raw data. We need to, like do some massive cleaning up. We need to do some data pre-processing. Then we need to use various methodologies, to discover some information from the data. could be it could be, if you have, for example, if you have data, current data, and you need to predict what is the weather for tomorrow, or what is the stock market value for tomorrow, or given some features of some animals or birds, you want to classify, categorize them into several categories, or you want to group them, based on some features like clustering. So data science is it's a big area where we try to find meaningful information. I would say frequently occurring things. Data science is all about like understanding frequently happening things, and it is more standard. While chance discovery is all about identifying very rare, unexpected, and potentially very useful events or happenings, or certain things which traditional data mining, data science methodologies would would fail. So I would say, if someone asks me how it differs from traditional data mining or data science, is its unpredictability. So it's all about finding anomalies. So even you'll be able to find something which is coming for the first time, or something happened one time, and then something very rare, new events. We are able to find such things compared to traditional data mining. And many a times these type of findings could be very significant practical usage. So very low frequency, but a lot of value for the community. And as you will soon hear from Professor Ohsawa, we cannot use traditional models, because traditional models, will not work for finding this type of, like unique events from data. So we need to use very specific methodologies, and I would say it's a much more advanced research area, or a much more advanced scientific discipline compared to data science, which involves, I would say, even philosophy, mathematics, cognitive science, AI, plus plus. So you can imagine, it is a huge discipline. Like Professor Osawa has uh, grown this discipline over the last, I would say, 25 years or so. So you can imagine it's a discipline by itself. And many a times, like I said, it is used for finding rare events. For example, in like detecting frauds, or for example in medical diagnosis, or for getting some business intelligence and things like that. So I guess that is a like a quick comparison between traditional data science and chance discovery. And now what we'll do is, I will let Professor Sawa to, I think he has some a short presentation to show all of us, and then, after that, we will have a common time for interaction. And I would also request, all the attendees to note down your questions, probably in the chat box, and you can also address to Professor Sawa or to myself, and then we will figure out how to answer and how to move forward. All right. So with that, once again, I would welcome all of you to uh, School of AI, Sai University, and this Fireside chat series number one. So over to Professor Sawa.
Yeah. Uh,
Fine. We can see the screen. Probably you need to. Fine. Perfect.
okay.
Perfect.
Okay. So let me go very briefly. So thank you very much, Ajith, for the very very so kind introduction about my work and my relationship with you. And thank you very much for this invitation. I'm very much honored to be invited here to speak. But I will try to be as short as possible. So this is about what I think and what I have been thinking. That is, chance discovery, I think, goes beyond data science because, as I said, chance discovery doesn't only cannot be realized just only by data science, but also should be also integrated with cognitive science and the various model-based sciences too. So it's an integration of data-driven and model-driven and human-driven sciences. So I have been working for business sciences for data analysis for business and also data analysis for natural phenomena such as earthquakes and weather changes, and also the human's health state. And then I have been working for creating systems of human society and some product and service systems based on the discoveries that humans do from data. So I have been working with various companies, including architecture companies and manufacturer companies and stock analysis companies, and also estate management companies, and also supermarket. So various companies, because they need some chance discoveries. So here is the definition of chance. So chance has at least 5 meanings according to Oxford Advanced Learner's Dictionary. So the first meaning of chance is uncertainty, and its probability is the second meaning, and the third meaning is a good time to do something. On the other hand, it has some negative meanings such as risks and accidents. So it's a complex word. However, I redefined it. Together with Peter McBurney, and he's now professor of King's College London, and a new definition by us of chance discovery is to detect an event that is significant for human decision making, which can be rare, as Ajith said. So that is when you encounter some event that is uncertain. Okay, so that is when you encounter an event, a situation or event from which you can think about the future. And if there are multiple futures, it means that you are in an uncertain situation. So at the time, you have to make some decision. And this decision is very important because you have multiple choices. And it's good time to do something, or it's good time to decide something. However, you have some risk of choosing a bad choice. So chance has, if it is defined in this way, it has at least these 5 meanings. So we decided to redefine chance and chance discovery. And apparently, if we define chance discovery in this way, it is very important because it means to detect events, even which is rare, that is important for humans' decision making. So this diagram shows a very brief concept. That is, it reflects my experience. That is, when I went to a supermarket, I went into the supermarket to buy some liquor because I like beer, and then I saw something that may look good to eat with beer, but it was quite expensive for me at the time. So I didn't buy it, but went to a shelf of snacks, potato chips and some other snacks. So it means that this food, that is dried squid in this case, because it is expensive, very few people buy it. It means that the frequency of this item is rare. So it's very low in the data of the sales. So if, as far as you just adhere to using machine learning techniques or statistical analysis methods, then maybe it's not easy to see or think what happens after somebody buys this dried squid, because it is rare. It's not easy to learn some patterns, including this dried squid. So this is chance, because it affects human beings like me. Okay. I just went to the supermarket just for buying beer, but just by looking at this dried squid, I didn't buy it. Maybe some other quite rich people may buy it, but I didn't buy it and went to decided to buy some other things. It affected my decision. Also, it affects some sales graph. So the problem is to how to catch this kind of item. So my solution was to visualize this structure and make human beings, such as sales clerk, to look at that figure, the graph which showed this kind of structure, and explained what that dried squid means to the market. So we had invented this kind of tool that is called key graph. It is very, very old. I published about key graph almost 30 years ago. Maybe at the time, some of you students were not born. So the black nodes represent some frequent items, and the clusters show some frequent clusters, and the red nodes show infrequent, rare events which connect multiple clusters. And at that time, this was my image. This was my in other words, model, abstract model in creating key graph. That is, there are some bases. Okay, this is basis. There are three bases of this building, and there is a roof that is shown by a red disk here, supported by the three bases. And each cluster in the right-hand figure shows each basis in this model. And the red node represents the roof. So in other words, some rare word, if the data is a text, the real world can be represented by the red node that corresponds to the roof, and the frequent items construct clusters, and each cluster corresponds to one basis in the left-hand side. So a document can be structured in this way. That is the assertion, a new concept may be represented being supported by some basic concepts that are represented by frequent clusters of frequent items. However, that was my first idea about key graph. However, when the marketers of some textile company used key graph, I was surprised that they used key graph in another way. That is, they showed the co-occurrence between the textile items and attached the real pieces of the textile and touched and look at that figure to understand that there are some materials of suit, and in the left-hand side there were also some material textile for making casual clothes. And in between them, there were some red corduroy items that did not appear frequently, that is, represented by red nodes that connect between the suit and casual clothes. And the marketers look at this and touch this diagram to explain the behaviors of the customers, that is, women. Okay, women who works at the office until maybe 5 o'clock or 6 o'clock may go out for eating at some drinking places or eating places by changing the suit from the suit to some more casual clothes. But changing from the suit to the casual clothes is not easy for fashionable women. So they like to change, be prepared with some easy clothes to change from suit. So based on this inference, by looking at this figure, the textile marketers invented this jacket that can be produced by using this new corduroy. And as a result, they successfully sold this corduroy to wide range of the market. So this is a successful scenario of chance discovery. So the point is that this item was rare, but by visualizing it and talking to each other about the latent scenario for buying that, selling that, So they obtained some new scenario, the new plans of cells. So that is, this cannot be just automated by using machine learning because the human's interpretation after human's communication realized this. Okay. And the point is that, another point is that they looked at key graph in totally different way from what I thought. That is, I invented key graph. So considering that it is a structure of bases and groups. On the other hand, these marketers looked at key graph as islands and bridges, islands of suits and islands of casual clothes, which are connected by the rare words or rare items, which are corduroy. So that is, two islands existed, and the customers moved from one island of suit to the other island of casual wear across the red new corduroy. So it's quite a different model in their brain. So this is the process of chance discovery that I previously proposed. That is about more than 20 years ago. I proposed this is a process. That is, the human beings need data for chance discovery from the market in this case, and they visualize, and then they look at it or communicate it with each other and obtain the discovery of some chances, and then they do some actions and look at the real world or real society or real market, and then they collect new data and go ahead to the new steps of chance discovery. So, however, one thing that is quite important is that they also, the participants of the process of chance discovery also had some images that are the model that we call feature concepts. So in the case of decision tree, it's a one methodology of machine learning. Here, the method runs this kind of tree structure. So it's for example, in this case, it's data from the victims of Titanic accident. So if you ask, if you ask, if men were more frequently victimized by the accident than women, then the answer is yes, and then and so on. So the victimized passengers can be clustered in this way in the tree structure. And in this case, maybe I guess that Professor Quinlan, who invented decision tree, had this kind of image in his brain. So based on this brain, image, that is a model, so he invented decision trees. And also for almost all other methods of machine learning and also data visualization, the inventor of the system or tool should have this kind of model in their brain that can be drawn in this kind of quite a simple illustration. And in my case, architecture was the original feature concept of key graph. On the other hand, for the users, so this kind of the new feature concept that's islands and bridges were more convenient. And also when I applied key graph to the analysis or visualization of humans' blood test data, so I used this structure, that is islands and bridges. In this case, so I collected the blood test data of more than 600 patients of hepatitis C. So it starts from the the lower left, which means quite a low level of hepatitis. Then the disease goes ahead to progress, and then go ahead to maybe quite a terrible situation such as liver cancers. However, on the way, if the patient get some good treatment such as the iron reduction in the blood, then So it start to be cured and the patient goes into a better situation, that is being cured. So this kind of visualization came out from the idea of the marketers of the textile company. That is, I borrowed the idea of islands and bridges. So the feature concepts plays quite a very, very important role in the development of algorithms for data visualization and also interpreting the result of data visualization for the users. And in this case, I used key graph to visualize the data of earthquakes. And as a result, that the red nodes that in the key graph, which was applied to this period, that is from 1985 until 1992. So corresponded to the focus of the great earthquake in 1995. That is 3 years after the data period. And in this case, so I used this feature concept. That is, there are two clusters of focal points. So in the so one is made of active fault numbered 24 and 34. On the other hand, there were some other clusters composed of the active fault number 29 and maybe 25 and so on. And in between them, the active fault number 39 was were stressed. And as a result, that active fault has encountered a great earthquake of magnitude 7 in 1995. So this is this structure. That is frequently quaking earthquakes before 1992 are corresponding to the basis, and there were 2 bases in this case, and the red node corresponded to the future earthquake. And so on. So let me skip the remaining slides because my message is very simple. That is, 2 things are very important. One thing is the process of chance discovery, where humans are involved and do interaction with AI and data visualization algorithms, and the other is the image of humans within the human's brain that is called feature concept. So if you have some success in applying one visualization method, not only key graph, but also other visualization methods or machine learning methods that are created based on one feature concept can be applied to other kind of data sets in different scientific or business domains. If the underlying structure can be, and also if the user's goal can be represented by the same feature concept. That is, if you have the same feature concept in multiple domains, then the same data visualization tool or the same machine learning tool can be diverted from one domain to another domain. So the process can be rewritten in this way. So in the case of textile, they had this diagram. This feature concept. However, before that, they had some image about their business success. That is, they wanted to change the market from a current situation that is represented by now here to the future market situation that is represented by next in this case. And then because they had this kind of image of their market strategy, they had this feature concept in their mind, and then they applied this feature concept in using and visualizing and seeing their visualization result. So therefore, as a result, they could verbalize their policy that they obtained after looking at the result of key graph. So in this way, that is, when the women in the office likes to go out for eating at the restaurant, they like to wear the clothes that is made by using item A. So this kind of visualization, verbalization can be obtains due to their original image that is feature concept. So this is just a summary. So because I don't like to conclude, because I like to continue studies and communication with you, and so I showed some success stories, and yeah. So however, this should be addressed to the questions from maybe Ajit, but I would like to say that it's hard to separate between good chances and rare noises. But as for the time being, so as I thought 20 years ago, I think that it's quite hard to automate the separation between chances and noises. Therefore, humans' interaction with machines are still quite necessary. Mm. So also in the process of chance discovery, where humans and machines do interactions, it's so it's not meaningful just to tell humans to do interaction with machines, but so give them some additional instruction. That is, draw some feature concept in the first place before starting your interaction with machines. Then I think and I believe and I found that the interactions of humans and AI comes to be a successful process of chance discovery. So these are my summaries. Thank you.
Thank you. Thank you so much, Yukio, for this wonderful introduction to this discipline. I guess most of our audience probably it is probably, as you rightly said, it's totally new for them, though it is a 30 plus year old discipline. But many youngsters, especially I think those who are new to university life, they are pretty much new to chance discovery. And I guess this talk and this fireside chat series would inspire them to learn more about AI, data science, and chance discovery in uh, the future. I'm sure that like there will be a lot of interest. Like I see that we have now a lot of data and we have computational resources. All we need is to roll up our sleeves, and we need our youngsters to uh, take the flag and work hard, try to find what's going on. Like we're talking about global warming and many other pressing issues facing I would say not just a country, but today we are working in a networked world, so we all should work together to solve some of our global problems. Like for example, like climate changes, all our UN SDG related goals. So we need such interesting scientific disciplines to flourish and take forward, so that we will make use of every chance or discoveries from from data to help humanity at large, so that we all can benefit. So at this point, if there are any questions from the audience, I'm just going into the audience chat box and I'm just picking up uh, questions. So, what is meant by chance discovery, which lead to data? So, I already mentioned this in the introduction. So, if you look back the recording, I've given the difference between a chance discovery and data science in a very simple way. So, if you can look into the uh, recording, probably you could find that. What's the difference between big data specialist and big data analyst and big data engineering? So specialist and analysis, I would say is very similar, but engineering is more towards, handling the data itself. So big data is something very different. So you need, databases, storage, and how you would, retrieve them for various analytical purposes. So that itself, is a, it's a discipline where we need to, have, storage devices. You might have heard of, like Amazon clouds. Nowadays, a lot of things are being stored in the cloud. And then, like we use computational methods to uh, analyze such data. And then, we try to find meaningful information. So again, like I said, depending on the data, for example, data could be in many forms, could be structured, unstructured. So depending on that, we need to devise suitable ways for storage and retrieving them, and then use various methodologies. And again, many a times data may have a lot of noise. We need to do a lot of cleaning up. So we also need to devise, methodologies for handling such things, and especially big data. Sometimes, you have data, it's not volume itself, but also velocity, like streams. For example, imagine if you have like thousands of video cameras monitoring some part of city or railway station or some event. Imagine the data coming in, and you need to monitor this. So you need not just understanding data, but also you need to do at some speed. And sometimes you need to like link with various other things as well to make some decisions. So big data mining is or big data analysis is it is like a very interesting area, totally posing a lot of challenges, a lot of computational resources. So I think that is a short answer for that. So one question is how one can become a data scientist. So yes, so it is pretty much like I would say if you study AI data science and then specialize, and that's about it. And then it's all about handling different types of data, getting more experience. So it is all, I would say, more hands-on than theory. Data science is all about hands-on than theoretical things. So unless you do it by yourself, you can't understand. Like for example, there are several libraries for data mining, data science, but unless you try it by yourself, you don't understand how it works. So I think basically once you finish your studies in the university for 2 3 years, you'll get there. And then once you finish your graduation, some internships with some industries, working on some projects, you will certainly become a specialist. So any other questions from the floor? Otherwise, let me ask like one question to Professor Ohsawa. So
Yeah.
I would say, like, for example, what is meaningful in one domain might be relevant in another. For example, you already, like mentioned about key graphs, and you have already developed a model for example, let us say earthquake, and you cannot use the same model for something else. So it should be
Mm.
very context aware, right? And
Yes, I think so. Yeah.
and designing new things starting from scratch, and and also it involves a lot of complexity, right? I mean,
Yes,
so
yes.
so how do we deal all these things in a practical setting, like from a practical point?
Yeah. So yeah, thank you very much for the two great question for me. And I think it's very, very hard. So in my slide set, I explained just four cases which were easy to be successful. That is, I applied the key graph method for which could be diverted from market data into earthquake data or linguistic data into marketing data. So it is not very, very new idea. That is, some previous researchers had already done some of the diversion of the algorithm for marketing into earthquakes. Due to the so superficially similarity between the structure of the post data or text data to the earthquake data. So, however, if the structure is not so similar, or if the structure bit of the relationship between the data set and the business purpose of the user, then the similarity is not so certain. Therefore, in this case, so we are now encouraging some users of chance discovery methods to draw their original feature concept. So that is in the case of so decision tree. I just imagine that Professor Quinlan will draw some so illustration in his own notebook that is like tree structure, and maybe Professor Hinton drew some so structure like neurons and so on. Therefore, in the case of ordinary business people, which who like to so choose and use data mining tools, I first recommend them to draw some illustration, so that illustrate the structure of the data set or the structure of the knowledge that they like to acquire from data. Then that works as the feature concept, and it works for choosing the most useful data mining tool, data visualization tool, or machine learning tool. And also when the machine learning the tool shows out some output, then the user can interpret the result in their own way. So that is my idea for the time being.
All right, all right. Yes, thank you.
Mm.
And a, a a follow-up question, like for example, like many a times these discoveries are rare, and have you ever tried some, like reinforcement methods, like some providing some rewards so that the system could, like improve the learning in the for future, future discoveries?
Uh, mm. Now, so when you say reinforcement, so do you mean some kind of reinforcement applying some kind of reinforcement running, or do you mean the reinforcement of some part of the method?
No, what I was asking is, for example, you're getting a positive result and you find it very good. The discovered or the
Ah,
chance
yeah.
discovered was good. So you give a reward to the system. Or if the system didn't give a positive outcome, you penalize it by, giving a negative, reward. So
Uh,
that is reinforcement learning. So have you considered something like that in the model at any point?
yeah. So I don't have a clear answer to this question, but so in a very, very wider sense of reinforcement, so I think that the business users of chance discovery are doing reinforcement learning in their own mind. That is, sometimes they fail, so make failures, and sometimes they make some successful chance discoveries. And of course, the cases of successful chance discovery is much of low frequency than failures. So when they encounter some successful chance discovery, they learn to choose the right visualization tool for themselves. So the tool that gave successful chance discovery to the company is not always useful to other companies. And as you said in the previous question, it is quite context aware. Therefore, they should learn context, and then therefore, they come to be better and better at chance discoveries. Sorry, my answer may not be very clear hit for your question, but that is the human based reinforcement learning for chance discovery.
Okay.
Mm.
Got it. So you mentioned, several success stories in your presentation, and I guess probably a lot more is not shown there. So may I ask you, like, if I ask you, which was the most important project in your entire, like your, in,
Yeah.
what sort
I
of
think.
impact it had?
Yeah, thank you very much for the good question. Good for me. So I think the most important about the COVID-19, so the suppression of COVID-19 expansion that we did following the order of Japan's cabinet secretariat. So here I invented some simulation tool rather than data visualization tool for the prediction of. May I share the slide once again?
Yeah, if you wish, please.
Yeah, thank you. Uh, mm, Maybe this slide includes it. Yeah. This is it. it's not about key graph, but it is still about chance discovery. That is, so in the in the case of COVID-19 expansion, so almost everybody looked at the left-hand cluster in FC2. That is, the red nodes represent infected people and blue nodes represent not yet infected people. So almost everybody looked at the left-hand side, but I looked at the right hand because these people are not yet immunized, so they may get infected. And it is easy in this right-hand cluster to get spread. Therefore, I propose to use the network model that represents the a feature concept for simulation in this case, and then we found some very interesting and very useful results. That is the result in this case was that when you count the number of people you touch for 1 week, whom you know, okay. So suppose this is represented by M0. That is the number of people you intentionally touch within 1 week. On the other hand, count the number of people you touch every week whom you didn't intend to meet. Okay? So one is intended, or the other is not intended. And if the later number is larger than the former number, then you are triggering the expansion of infection spread. That is, so you should count the number of people whom you don't know and whom you don't you know, and compare these two numbers. Then you can estimate the risk of your behavior in stimulating the infection. This has been published in PLOS ONE, and the minister of our nation announced. Just borrowing my, or maybe stealing, because he didn't cite my paper. he may have stolen my paper to announce to all the nation in Japan, and as a result, as a matter of fact, the number of infected people has really decreased after 1 week after his announcement. Yeah, so I think definitely this is the most high impact recently. Yeah.
Thank you.
Also,
thank you.
Yeah. Good.
Very nice. Very nice. So I think it's a real life illustration, and I am sure that many of our listeners would be inspired to study chance discovery from now onwards, as I understand. Yes. So a couple of questions from the audience. I think one is, so difference between AI and data science. So AI is all about, mimicking, humans, and data science is all about playing with data. So AI with data is machine learning and data science. So if you study AI, you can eventually, do data science as well. I'm trying to answer the questions, from the chat box. There are a few questions, and machine learning and data science are very much connected. So machine learning is a subset of AI, and machine learning is mostly data driven. So data science and machine learning goes together. So where you study all this supervised, unsupervised learning methods for various data mining tasks. And so I think scope, I think if you look at, the world now, AI is everywhere. So we are seeing how the world is getting changed because of the influence of AI at large in many, it's not only our life, but also the way we do business, way some, professions work. So imagine looking at an MRI scan, we can tell that, some disease is coming, something like that. So we are able to predict, some diseases. So AI is, taking things in a very different way. So I think future is getting, it will get only better, because I would say AI is still at its infancy. A lot of things needs to be done, and a lot of work is going on. So I think it's a very good field. AI, data science, all these are very interesting scientific disciplines, especially for youngsters who want to, look into this field. Any other questions? I have a common question to be cleared. We know that AI creates unemployment as it is capable of doing human things easily. Since the topic is about AI in business, Do you think it'll reduce unemployment level and increase employment that would help humans? Yeah, very nice question. So I think, see, we should not consider AI as something to replace humans. So we should always think AI is to augment what we are doing. So, so basically, if you look at all this, modern progress of AI, looking at uh, generative AI tools from GPTs to media to the impact it is making in several disciplines. There'll be a lot of, I would say, replacement of like certain simple jobs using AI. But at the same time, if you're upgrading our skills to use AI to augment our productivity, imagine, if I'm able to do certain task, I will be able to do 10 times the work if I use AI to augment my potential. So we should always see AI as something that could be used to augment our productivity. But if you
Mm.
just watch the show, probably like it'll be like tsunami. it will it will it will sweep us away. So it's very important for us to like study the latest like technologies, methodologies, whichever profession you're practicing. If you're doing some admin work, you should be able to use AI basic tools to analyze like worksheets, like composing emails, composing like reports, understanding various things using AI. So that will all help us to improve our productivity. So I always see AI as a as my positive aspect. Not It will not take over us in any possible way. What are the opportunities the fields in between ML and data science? So it is same thing, and like I mentioned, uh, it will be there, and we need these technologies to help us in the long run. I think developing countries, I think we need to scale up our economy, and then AI is one, I would say, a good boon or a blessing to make use, and then we can scale up. We can imagine how Uber is working, Uber or Swiggy, all these apps. For example, Swiggy doesn't have a single restaurant, and they are one of the biggest food delivery chain in India. Likewise, Uber, they don't have a single taxi, but they are one of the biggest taxi companies in the world. So all we need is like AI, and like all we need is ideas, and using AI we can actually do wonders. Like likewise, Airbnb, Amazon, Alibaba, you can see several companies during the last like 10, 15 years, how they have scaled up their productivity. So if you use AI for the right cause, I think like developing countries can do a lot of things in the coming years, and especially a country like India where we have huge youth population. This is your century, your period. I think you need to like capitalize this moment, and like I said earlier, all you need is ideas, roll up your sleeves and work. So there is, I mean, AI. So there are also like a negative, I would say, publicity that AI could be harmful. Robots would swarm and like could take over communities, societies, countries. So these are more, like I would say, very fictional, and that more like movies. But if you look at from a scientific discipline, like I said earlier, AI has to go a long way. We should use AI for the benefit of the community, humanity, so that it can augment our life, our productivity, our society, our country, the world. So always, we should see things from a positive side, not from from a negative side. All right. So any other questions? If no questions, any other questions from the audience? So yes, bias and discrimination is often a problem, basically, because when you train a model, because it is based on that model, and then if you use that model to, like to make decisions, and then it can, sometimes generate, decisions which which you don't want. For
Mm.
example, if you develop a model to, like for example, like a loan application. So if you have a, like a system that providing inputs of the customer, and the system automatically gives you a response that to give loan or not. Okay, so such a model might work well. For example, if you're just buying a model that worked in US, probably it will not work in India, or vice versa. If you develop a model in India, it might not work in the US. So we need to really customize, and a lot of other factors. For example, there could be, demographical things, cultural issues, social aspects. So we need to build a lot of things inside to get a, very nice model. So big data specialist means, yes, big data specialist means you need to handle, first of all, big data, and then analyzing it. And finally, like all the way from data engineering, like I mentioned earlier, cleaning, pre-processing, analyzing, and like getting all these reports and final knowledge to the stakeholders. All right. Any other questions? So if no questions, I guess let us wind up. And
Yes. Participants, if there are any further more questions, final call, then probably we might be winding up.
what degree we want to learn to work in ML? So basically, I would say you need a BTech degree in AI, or a BTech degree in data science. Like I said, AI is more like a superset. So if you study AI, you can actually later work in data science. You can later work in, any subfields. So, but if you want to specialize in data science, you'll only, like handle with data related algorithms and related things. Can
Um,
we store files in data science? So data science, is like a big discipline. Like I said, it composes of, data storage, pre-processing, analysis. So it's a huge process. So storage is actually part of data science. So like I said, especially if you have big data, you also need to find ways, or find the you need to design, how to store these huge files so that you can retrieve, for various analysis. Fine. Okay. So if no questions, let me take this opportunity to thank Professor Yukio Ohsawa for spending his valuable time on a Saturday afternoon. And
Thank you very much.
I want
Thank
to,
you very much for everybody of you too. Thank you.
on behalf of all of us, special thanks. And I also want to thank all the attendees for, joining us. And if you have any, further questions, you can always, contact our team members. So probably, they will give you the contacts in the chat box, and you can always write to them. And those who are staying close to the campus, you can always, visit our campus.
Mm.
You'll be able to interact, with some of our faculty, and, understand how these things are done, etc., etc. Okay.
Yeah, yeah,
So with that, I, wish you a happy weekend. And Professor Sava, I think, we should catch up very soon.
yeah.
We should try to meet somewhere sometime soon.
Yes, yes. I hope so too. Yeah. So I enjoyed very much, and yeah, I was surprising to see that Ajit is answering all the questions so quickly, and it's a miracle too. So yeah, yeah. Great scene. Uh,
So here we are handling big data, so we don't have time. So time.
okay, I will try to visualize all the questions by key graph and send it to you.
Yeah. Fine.
Maybe great.
Yes. Have a good afternoon. Thank you so much. Thank you.
Thank you.
Bye. Bye.
Bye.
Thank you
Eh,
all. Thank you.